Hello everyone, my name is Sridhar and I am from Computer Science and Engineering Department. And today my topic is about biomass energy from waste to power. Introduction to biomass energy. Biomass energy derived from organic materials such as plant and animals waste. It is considered as a renewable source as it can be replenished naturally. This form of energy can help reduce reliance on reliance on fossil fuels and lower greenhouse gas emission. Here, the biomass energy is a device which is obtained from organic matter like such as the plants and animals, and it is also a renewable energy source, which is which would be couldn't extinct, and this form of energy can help reduce reliance on the fossil fuels, and we can use those fuels, biomass energy fuels instead of the fossil fuels. What is biomass? Biomass refers to any biological material that comes from living or recently living organisms. Common sources include agriculture residues, food waste, and forestry byproducts. Biomass can be converted into various forms of energy, including heat, electricity, and biofuels. Here, biomass refers to biological materials which comes from living organisms like all the living organisms. And here the common sources of the biomass are agriculture residues and food wastes and forest byproducts. And the biomass can be converted into various forms like energy, including heat, electricity, and biofuels. Types of biomass feedstocks. Here, the biomass feedstocks can be categorized into three main types: dedicated energy crops, agriculture residues, and waste material. Here, the biomass feedstocks are categorized into three parts, which is like energy crops, agriculture residues, and waste materials. And dedicated energy crops are grown specifically for energy production, such as switchgrass and miscanthus. And here, the agriculture residues include leftover materials like corn stalks and wheat straw, while waste materials can be municipal or industrial. Biomass conversion technologies. The conversion of biomass into energy can occur through several processes, including combustion, gasification, and anaerobic digestion. Here, the combustion of biomass into energy can occur through several steps like processing it and including combustion and gasification and anaerobic digestion. Combustion involves burning biomass to produce heat, which can be used to generate electricity. Here, the combustion is involved in burning biomass to produce heat, and which can generate electricity. And gasification converts solid biomass into a gas, which can be used to produce electricity as a fuel source. Now let us discuss about combustion process. In combustion process, biomass is burned into controlled environment to generate heat. This heat can be produced steam that drives turbines for electricity generation. Combustion is most straightforward method but can release pollutants if not managed properly. Here, the combustion process is nothing but the burning of the biomass and to generate heat energy. Here, this can be helped to use like to produce electricity by using turbines, and the combustion is a most straightforward method where the pollutants are released if it not managed properly. Now let us discuss about gasification. Gasification transforms biomass into synthetic gas, which is also known as syngas, through high temperature processes. This syngas can be used to generate electricity or converted into liquid fuels. Gasification is considered cleaner than combustion, producing fewer emissions. Let us discuss about anaerobic digestion. Anaerobic digestion is a biological process that breaks down organic matter into in the absence of oxygen. This process produces biogas, which primarily consists of methane and carbon dioxide. Biogas can be used for heating, electricity generation, and vehicle fuel. Here, the anaerobic digestion means the digestion which is happens in the absence of oxygen, and this process produces biogas, which primarily methane and carbon dioxide. And the uses of anaerobic digestion is It is used for heating and electricity generation and as a fuel for vehicles. Environmental benefits of biomass. Biomass energy can significantly reduce greenhouse emission compared to fossil fuels. It helps manage waste by converting into usable energy, reducing landfill use. Biomass can also promote soil health and biodiversity when agriculture residues are returned to the soil. Economic impacts. Biomass energy production can create jobs in rural areas, boosting local economies. It can provide a stable income for farmers and landowners through the sale of biomass feedstocks. Investing in biomass infrastructure can enhance energy security and support local energy markets. Challenges of biomass energy. Biomass energy production can compete with food production for land and resources. There are concerns about deforestation and biodiversity loss associated with large-scale biomass plantation. Proper management practices are necessary to ensure sustainable biomass supply chains. Here, the biomass energy production can be compete with the production for land and resources. There are some concerns about the deforestation and biodiversity in the large-scale biomass plantation. Proper management practices are necessary to ensure sustainable biomass supply chain. Biomass sustainability. Sustainable biomass practices focus on minimizing environmental impacts while maximizing energy outputs. Certification systems are being developed to ensure biomass is sourced responsibly. Sustainable practices include using waste products and managing land responsibly. Case study. Biomass power plants. Several countries have successfully implemented biomass power plants to utilize local waste. An example is Sweden, which generates a significant portion of its electricity from biomass. These plants can create jobs and provide reliable energy while reducing waste. Here, some countries like Sweden are improving the biomass power plants and which are giving jobs to several and provide a reliable energy source for them. Biomass in transportation. Biomass can be converted into biofuels such as ethanol or biodiesel for transportation. These biofuels can help lower greenhouse gas emission from the transportation sector. The use of biomass in transportation supports energy diversification and security. Technological innovations. Research and development are going to improve biomass conversion efficiency and reduce cost. Innovation include advanced biofuels and second generation bioenergy technologies. These advancements can enhance the viability and competitiveness of biomass energy. Policy and regulation. Government policies play a critical role in promoting biomass energy development. Incentives such as tax credits and grants can encourage investment in biomass projects. Regulatory frameworks are being established to ensure sustainable practice in biomass production. Global biomass energy trends. The global biomass energy market is expected to grow significantly in coming years. Many countries are setting ambitious renewable energy targets that include biomass. Emerging technologies are increased awareness are driving this growth. Community engagement. Local communities can play a vital role in biomass energy initiatives through participation and support. Education and outreach programs can help raise awareness of biomass benefits. Engaging stakeholders ensures the project meets local needs and priorities. Here, the community engagements like the local communities can play a vital roles in the biomass energy initiatives. And here we can initiatives through participation and support and the education and outreach programs can help the raise of awareness in of biomass benefits and engaging stakeholders can also ensure that they can engage the biomass usage. The future of biomass energy. The future of biomass energy lies in sustainable practices and innovative technologies. Diversifying biomass feedstocks and enhancing conversion methods will be crucial as the demand for renewable energy grows. Biomass will play an essential role in energy landscape. Here, the future of biomass energy is sustainable, is lies on sustainable practices and innovative technologies. And it's a diversifying the biomass feedstocks and enhancing conversion methods will be very crucial. Conclusion: biomass energy represents a promising solution for waste management and energy production. Through sustainable practices and technological advancement, biomass can contribute significantly to greener future. Collaborative efforts among stakeholders will essential to realize its full potential. Here are some references of biomass energy and biomass energy basics, which is taken from the US Department of Energy, Energy Efficiency and Renewable Energy. The role of biomass energy in sustainable future. It is taken from International Renewable Energy Agency IRENA and biomass a renewable energy source. National is taken from National Renewable Energy Laboratory NREL. And this is all about biomass energy from waste to power. Thank you.